Okay, good morning, my friends. This is problem 5.16. Problem statement, find the reactions at A and the tension in cable BC. I have my free body diagram already drawn. I'm sure it looks very similar to what you have. So with all these type of problems, I'm going to start with the equilibrium equations. So there are three of them. The first one I'm going to use is the equilibrium of the forces in the x direction. Looking at my free body diagram, I notice there's only one of them, and it is the reaction at point A due to that smooth pin connection. Since this is in equilibrium, the summation of the forces in the x direction is equal to 0. That gives us now that AX is equal to 0. We'll kind of put that over here. AX equal to 0. All right, that worked out pretty nicely. I'm now going to go to equilibrium of forces in the y direction, which there looks to be several of them. So we've got a AY, of course, is the reaction in the y direction at the smooth pin connection at point A. We will have a BY. We will have a DY. And we will have a CY being the reaction to the cable. A couple things that I'm going to need to take care of before we kind of fill that in. Kilograms needs to be converted to newtons. So we'll do that down here. 200 kilograms times 9.81 gives us 1,962 newtons. And then 350 kilograms times 9.81, I think is 3,433.5 newtons. So if you are not getting an answer close to mine, or you're very close but slightly off, you might want to look at your conversion factor. Keep in mind, in class, we have emphasized the importance of using 9.81. All right, we've got everything converted to, or well, I will say we've got the masses converted to newtons. So let's get what we kind of fill in our equilibrium equation. There's no value for AY. BY will be negative. It is because the weight is pulling down. Notice I have that on my free body diagram. So negative minus 1962 newtons, minus 3, 4, 3, 3.5 newtons, plus CY. That whole thing is equal to 0. Combining those terms that are alike, we end up with AY minus, let me calculate that real quick, 1962, 3433.5, so minus 5395.5 newtons plus CY is equal to 0. So that's one equation with two unknowns. That tells me that we're not ready yet. There is the third equilibrium equation, so we're going to take the summation of the moments about point A. We could have chosen point C. I think I've shared in class that I typically choose the point that has typically choose the point on the left. It wouldn't matter. We could have again chosen about point C and just chosen about point A. All right, so the summation of the moments about point A. So AX is a non-player because its perpendicular distance between where the force is being applied and the point rotating is 0. AY is also a non-player for the same reason. The point B is a player. Point B is a player. So 1962 times 1.6 meters. Point B is being applied 1.6 meters away from point A. Point D is a player. 3, 4, 3, 3.5 newtons times 3.2 meters. So point D is 3.2 meters away. And finally, point C. Point C is unknown, so we'll use the CY as our force, and it is 4.8 meters away from point A. As I've done in class, I'll now go and put the signs for the moment. Keep in mind, counterclockwise is positive. So counterclockwise is considered positive. The 1962 Newton force being applied at point A causes a clockwise rotation or clockwise moment, so it is negative. The 3,433.5 Newton force also provides a negative moment, and CY provides a positive moment. Putting those numbers in the calculator. Negative 3139.2 Newton meter plus negative 1098.7.2. I think it's 0.2. Yep. Newton meter plus 4.8 times CY is equal to 0. Combine these terms, they're alike. That's negative 14,126.4 plus 4.8 CY is equal to 0. Add working to isolate CY. Adding 14,126.4 Newton meters to both sides. Finally, dividing both sides by 4.8, we get that the value of CY is 2,943. Let me double check that that's correct. Divide by 4.8. Yep, 2,943 newtons. Go ahead and put that up here so I have it. CY is 2,943 newtons. Right. We can definitely use that information now that we have that. We can substitute it in for CY. I'm going to do that over here. Summation of the forces in the Y direction are equal to AY minus 5,395.5 newtons plus 2,943 newtons equal to 0. Combine those terms, they're like. We get AY minus 2,4. Oops, that's not very nice. Erase that real quick. There we go. AY is equal to, I did it again. Erased it again. One more try. 2.5. 2.5 newtons equal to 0, giving us that AY is equal to 2.5 newtons. Go ahead and record that up here in our, what I call the scorecard. AY is equal to 2.5 newtons. I'm going to go ahead and indicate that that's in the up direction, and that CY is in the up direction. So that is our final answer for problem 5.16.